How about we play poker today? All right. Let me show you the formula for combinations. Yeah, will you sit down there? Okay, so if you use the NCR button, then the calculator uses a formula to calculate the combinations. And the formula is, and one way to write it is n choose r. That's how we're going to write it today, because that's just the way it's done in the real world. N factorial, what does factorial mean? Factorial means, so 4 factorial is 4 times 3 times 2 times 1. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? So the formula is n factorial divided by r factorial times n minus r factorial. So if I had 8 choose 3, so I have 8 books and I get to take 3 to school. It's a combination. How many possibilities are there? Well, 8 times 7, 6, 5, 4, 3, 2, 1. And I divide that by 3 times 2 times 1 times the difference between n and r, which is 5. So 5, 4, 3, 2, 1. And then we just play a massive cross-out game. And that 6 kills those. So there are 56 ways to bring 3 of the 8 books to school. 3 times 2 is 6. So 8 choose 3 is exactly the same thing as 8 choose 5. Right? If you put 3 books in the backpack, you leave 5 out. So some of you aren't paying attention, namely Colette and the Tanner boy. It's on the record now that you weren't paying attention. It'll be forever on my website. So putting 3 in and leaving 5 out is the same thing. So putting 5 in is the same as putting 3 in. And in the formula, you can see that, because it would be 8 factorial over 5 factorial times 3 factorial. And no matter what order you put the 5 and the 3 in, you're going to get the same number. Right. So, yes. So, you can divide them out that way. I recommend you just use the NCR button, but that's how the NCR button works. No. Okay. Yes, it happens all the time. Like right now, the people listening to this have no idea what you guys are talking about. Right, right. And it takes 87 penguins. So. Yeah. Or you can substitute 3 penguins for 1 walrus. So it's up to you. It's either 87 penguins or 29 walruses. Okay. Those of you at home, I'm sorry, you have no idea what just happened. Okay, so we're going to play poker. There are lots of different versions of poker. You could play 5-card draw. You could play Texas Hold'em. Shh. You could play lots of things. We are going to play 5-card stud, which is the simplest form of poker. You get 5 cards, and that's it. No trading, no borrowing, no using cards on the table. So we are going to calculate how many ways there are to get each poker hand. So the first question on your worksheet says, how many cards are in the deck? 52. How are those cards made up? Four suits, ace through king, so there are 13 numbers and 4 suits. Now, are poker hands combinations or permutations?
Math sucks.
Well done, Connor. You now get fined 5 penguins. So, are poker hands combinations or permutations? So, if I'm dealt a 2 and then a 3, is that different than being dealt a 3 and a 2? No. Now, but in poker, numbers are more important than suits. Heart. No, a suit is heart, club, spade, or diamonds. So, numbers are more important. Okay, but the numbers can be ordered however you want. So it's a combination. Suits, we run into other problems. So I need to show you one thing if you're going to really understand how this works. We are going to be calculating the number of possibilities for every number and the number of possibilities for every suit. And if I lined out my numbers, 2, 3, and 4, and I were to change the suits, so let's say I had 2, 3, 4, heart, spade, club. Is that different than 2, 3, 4, club, spade, heart? Yes, those are different hands. So if the numbers remain stationary and the suits change, that changes your hand. I mean, you might still have the same score, but it is a different hand. It's a different possibility. So we're going to multiply the number of possibilities for the numbers by the number of possibilities for the suits. But it gets a little bit more complicated. Let's suppose you have a full house, or you have 2 pair. Okay, and this is really the hardest thing that we'll have to do. Is changing, well, let me write it this way. So let's say we both have full houses. The full house is a set of 3, a set of 2. Okay? So if I have king over queen, and you have queen over king, are those 2 different hands? Yes. Who wins? King over queen wins. So if I want to calculate the number of possibilities to get a full house, because kings and queens, if you trade them, that changes your hand. We have to treat those separately. If you have 3 queens and I have 3 kings, I win. You have 3 queens, I have 3 kings, I win. No, because I have 3 and you have 2, and you have 3 and I have 2. So like this. Okay, hold on. We have too many side conversations going on, so let me explain this one more time. So if this is me and this is you, king and queen? Oh my goodness. Peyton, they're cards.
Well, I know they're cards, but I mean king over.
3 kings, 2 queens. 3 queens, 2 kings. Yes. There is no way we're getting through this today. Okay, so the other way to view this, let's suppose, now listen carefully, we both have 2 pair. And 2 of each. I have 2 kings and 2 queens. You have 2 queens and 2 kings. Do we have the same hand? Yes. Okay, so both of these contain 2 of the 3 possible numbers in the deck, right? We have ace through king, 13 numbers. Each of us, in both sides, have 2 versions of the 13 numbers. So we could either calculate this using 13, choose 2. There are 13 numbers, and we both have 2 of them. Or we could calculate 13, choose 1, and times that by, hang on. So I could say that the first one has 1 of the 13 numbers, and the second one has 1 of the remaining 12 numbers. Well, it doesn't matter which one you like. They both exist. So in your calculator, calculate 13, choose 2. Yes. 13C2. 78. What is 13 times 12? What is that? 156. Now wait a minute. Why are those different? Here's the reason. If I look here, is the top hand and the bottom hand the same? Are those two the same? Yes, because there's the same number in each. So in the top portion, are those two hands the same? No. So is it going to have more or less possibilities than the other one? This one is going to have more because order matters. This one is going to have less because order does not matter. Right? These are equal. King, queen, and queen, king are equal. 12 equals 21. But up on the top, king, queen, and queen, king are not equal. But this is really tricky because they're both combinations. So this is a single combination. We pick them together because it doesn't matter what order they're chosen in. Here is a double combination. And whenever you multiply two combinations together, you're actually calculating a permutation of two combinations. So the question we ask is, does changing the order matter? Up here, the answer is yes. If changing the order matters, we calculate them separately, which gives us more possibilities. Yes. For this one, you have to do it that way. In this one, does changing the order matter? No, so we calculate them together. And it's the difference between a 2 and two 1s. Right. So there are 78 ways to get two pairs, and there are 156 ways to get full houses. But there's more to it. We're missing some stuff. Yeah. No. No. Because there are suits involved too. So there are other things that we haven't put in. But you need to remember this. If switching changes the hand, then you calculate them separately because it's a permutation. Because KQ and QK are not the same thing. If switching them does not change it, you calculate them together because it's a single combination. If you can understand that, then everything else we're going to do shouldn't be too bad. Okay, so the next question asks, how many possible 5-card hands are there in poker? Well, how many cards are there? 52. How many cards are we picking? 52, choose 5. So 52 choose 5 is like 2.5 million. Almost 2.6. Okay, we'll do 2.6 million. Whatever it is, it's on your calculator. Okay, now we're going to go through and figure out how many possibilities there are for each particular hand. Yes, Connor? We haven't done any odds yet. Ask it when we get there. Okay, royal flush. So a flush is 5 cards of the same suit. 5 hearts, 5 diamonds, 5 clubs. A straight is 5 cards in order. So a royal flush is 5 cards in order that are also the same suit. How many ways are there, or sorry, a royal flush is the highest straight flush. So a royal flush starts with 10. 10, jack, queen, king, and then ace. Ace can either be a 14 or a 1. Yes. So how many royal flushes? It would be a bad idea to show your cards to other people. So how many royal flushes are there? There are only 4. There's a royal flush with diamonds and hearts and clubs and spades. So 4 is the answer. But Let me show you how to calculate that in the method that we're going to use to calculate everything else. Now, we already know that reordering your cards does not change it, right? So we're going to assume for the rest of the day that as soon as you get your cards, you put them in numerical order. And that's the order we're going to use. Because it doesn't matter what order we choose, so we're just going to choose the one that makes the most sense to us. Okay? So when you get your cards, you put them in order. Every time we do a calculation, we're going to find the possible numbers, ace through king, and then the possible suits, and then we multiply them together. And sometimes we have to do this over and over for a particular hand. So we have 5 cards in a royal flush. How many ways are there to pick the first card, which is the lowest card? The number, just the number, not the suit. How many options do I have for card 1? No, not for a royal flush. I don't even have 4. 1, what is it? It's a 10. The first card has to be a 10. So that would be 1, choose 1, which is 1. How many options do I have for card number 2? 1, because it's going to be a jack. And what about the others? So this is 1, choose 1 to the 5th, which is just 1. It didn't do us any good. Hang on. We'll go on to suits. So there's only one way to pick the number. It's a 10. And once you know the 10, you know all the others. How many ways are there to pick the suit on the first hand, the first card? So 1 in 4. Because there are 4 suits. So this card has to be a 10, but it could be any of the 4 suits. So 4, choose 1. Well, once I know what this card is, how many options do I have for the suit in the second card? 1. So 1, choose 1. And the next one? 1, choose 1. So this is going to be raised to the 4th. Now, that doesn't matter, and that doesn't matter. What is 4, choose 1? 4. Well, 4, choose 1 is equal to 4, choose 3. Remember that. That's going to be important in a little bit. When these two numbers add up to be that, remember, it starts with 1s, and as you work in, they match. So 1 equals 1, 4 equals 4, 6 equals 6. Okay, so that was 4. Now, a straight flush. What is a straight flush? 5 cards in a row of the same suit, but they have to be in order, and it doesn't start with a 10 it can start with an ace. It can't be a 10. Yes, it could be, but it can't be a jack. It can't be a queen. And it can't be a king, because you can't wrap back around. You can't do jack, queen, king, ace, 2. That's breaking the rules. You can use the ace as a 14. Yeah, well, it could be a 10, except a 10 is actually called a royal flush. Right? If it starts with a 10, it's not a straight flush, it's a royal flush. So how many options do I have for it can end in a 10, it can contain a 10, it just can't start with a 10. How many options do I have for the first number? Nine, choose 1. So for the first number, I have 9, choose 1. What about the second number? Well, if I know the first number is a 6, then all the other numbers are chosen, right? Well, remember, we ordered them as soon as we got the cards. We're assuming numerical order. Yeah. Okay, so then I have 1, choose 1 to the 4th. Because the other 4 cards don't matter. Once you know the first one, you know all the others. Okay, what about the suits? How many options do I have for the first suit? 4, choose 1. What about the second suit? There are 4 suits, right? Once I pick the first suit, then I know all of the other suits, so it's 1, choose 1 to the 4th. Now, we're going to stop doing this because it's pointless. So if it's 1, choose 1, we're just going to forget it from now on. Well, they won't all have them, but if it does have one, we'll just forget it. So what is 9, choose 1? 9 times 4, choose 1? 4, so there are 36 straight flushes. And just so you know, if you divide that, 36 divided by 2.5 million, it's like 1 in 10,000 choices. I mean, it's ridiculously small, the chance of getting one, yeah. Okay, 4 of a kind. Tell me what 4 of a kind looks like. 4 of the same number. What about suits? What's that? So how many of the suits do I have inside that? Inside that 4 of a kind, how many suits are there? All 4 of them. Okay. What about the other card? It does matter. In our calculation, it matters. So the number on the 5th card, tell me about it. It can't be anything. It can't be whatever the number in the 4 of the kind was. Okay? So inside here, I have 1 number and 4 suits. And over here, I have 1 number, but it's not a 3. Well, right. I mean, there isn't one. It won't happen. But when we calculate it, we have to factor in that it's not a 3. Okay? And that could be any suit. So, how many ways are there to choose the number of the 4 of the kind? Yes, could be anything. Are there any restrictions on these numbers? No. It could be anything. So 13, choose 1. What about the second card? 1, choose 1, 1, choose 1, 1, choose 1. Okay. Wait, we're still on numbers. We're not doing suits yet. Okay, so that's number. Let's look at suits. Now, I have an important question. If I have all 3s, okay, and I change the suits around, does that change my hand? No. So let's go back to what we learned before. If KQ and QK are equal, it's a combination, and we do the calculation all at once. So there are 2 options here. We either do 4 choose 1, 3 choose 1, 2 choose 1, 1 choose 1, or we do 4 choose, no. So we're either going to line it out, 4, 1, 3, 1, 2, 1, 1, 1, or I combine them all together. No, there is no we're not ever going to use an exclamation point. I know, we don't use that formula. We use our calculators. So, no, Peyton, I'm saying never, ever are you going to push the exclamation button. Okay, so here's the other way to look at it. Of the 4 suits, how many suits do we pick? All 4. So do you see the difference between 4 choose 4 and 4, 1, 3, 1, 2, 1, 1, 1? This one only applies if switching the suits changes the hand. No. If switching the suits does not change the hand, then you do them all at once. And this one makes more sense. If you have 4 of a kind, do you get to pick the suits? No, because they are all there. Well, what is 4 choose 4? It's 1. If you have 4 books, how many ways can you bring all 4 to school? 1 way. You bring them all. So the suits would be 4 choose 4. But this is going to come up again. We have to decide a lot. Does changing the order change the hand? If the answer is yes, then we multiply them the long way. If the answer is no, then we multiply them the short way. Okay, so that takes care of these 4 cards. How many ways are there to choose the number on the last card? There are only 12 numbers left. I already used the 3. So 12, choose 1. Right, so what is the suit of the last card? 4, choose 1. It could be any of the 4. So this is easy, 13. This is easy, it's 1. That's 12, and this is 4. So what is 13 times 12 times 4? 624. Okay, next one. Full house. 3 of a kind, 2 of a kind. Okay, so if I switch my 4s and my Qs, does that change the problem? If I had Q, 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 4, 4, or 4, 4, 4, Q, Q, that's definitely different. Yeah, so 3 and 2, that's a full house. So if switching it changes, then we pick the numbers separately. So I have the option of 13 choose 1, 12 choose 1, or 13 choose 2. Right. So either I pick my first number, Connor, I pick my first number from 13 choices, and I pick my second number from 12 choices, or I pick both numbers from 13 choices, and that's different. Which one is it? Well, does switching change? Yes, so we do it the long way. So that's how we pick the numbers. Okay, so let's pick the suits. So imagine you have 3 queens. Does changing the suits change your hand? No. So do we pick these suits together or separately? Together. So it's going to be 4, choose. How many suits are in there? 3. Well, I know what 4 choose 3 is. It's the same as 4 choose 1. So this is 13 times 12 times 4. And what about the suits for the last 2 cards? Does changing the suits change the hand? No. So do we pick them together or separately? Together. So it would be 4 choose 2, which is 6. So 3, 7, 4, 4. Okay, I think we're getting the hang of this. That's a full house. Now, a flush. What is a flush? All the cards have the same suit, but there's a catch. They can't be in perfect order. Okay? Right. Because if I have all hearts, I have a flush. But if I have all hearts and I have 1 through 5, that would be a straight flush, which is worth more. So there are 2 ways to do that. Either we weed out the straight flushes in the beginning, which is really hard to do, or we subtract them off when we're done. It's really hard to weed out the straight flushes while you're doing the calculations. The easy thing to do is calculate all the flushes and then just subtract off the straight and the royal flushes. So, what do I know about the numbers of those 5 cards? What can you guarantee about those 5 numbers? They're all different. Because if 2 of them are the same, it's not a flush. Okay? So, if I change the order of the numbers, does that change the hand? No. So am I going to pick those 5 cards separately or together? Together. So it would be 13, choose 5. Right? Because if order does not matter, we pick them together. If order does matter, we pick them separately. Okay. So now what about the suits? How many ways are there to choose the first suit? 4, choose 1. What about the second suit? 1, choose 1, because it's already decided. So what is 13, choose 5? 1287, and I multiply that 1287, and I times that by 4, 514. But what's wrong with this number? It has too many numbers in it. How many numbers do I want to take away? I need to get rid of 4 royal flushes and 36 straight flushes. So I just subtract off 40. And trust me, that's a lot easier than trying to weed them out in the beginning. So it would be 5108. Okay, straights. What do I know about straights? They're in order. Are there any limitations on that order? Oh, good. We have to worry about flushes. Should we try to weed the flushes out now? Never. You don't ever want to do that. In order, and it can't be all the same suits. The trouble with trying to weed out the flushes is you could say the last one is different, or maybe the second to last one is different, or the third to last one is different. It's way too many possibilities. Yes, 2. 4 of them could be the same. What about the numbers? Am I limited on which numbers I'm allowed to pick? How? They have to be in order, which means I can start with a 10. 10, jack, queen, king, ace, that's a straight. I can't start with a jack or a queen or a king because you run out of numbers. If you tried to do jack, queen, king, ace, you would need a 2, and you're not allowed to do that. So this is not jack, queen, king, ace, 2. That is not a straight because this is either a 14 or a 1. It can't be both. So that doesn't happen. But I could put a 10 over here. That works. So if I get my straight and I put it in order, how many possibilities are there for the first number? So how many options are there for this number? What numbers could go there? Ace, 2, 3, all the way up to 10. So this number is 1 out of 10. Because it can't be a jack, it can't be a queen, and it can't be a king. Okay? So, what about the suits? Or, sorry, and then how about the second digit? There's only one choice. Third digit, one choice. So there's a bunch of one choose ones. Okay? What about the suit for the first card? 4 choose 1. What about the suit for the second card? 4 choose 1. 4 1. 4 1. Well, do I want to put the 3 here? Because if I put the 3 here, then I got to go back through and count up how many if I put the 3 here and put it here and put it here. So we're just going to assume they're all different. 4 choose 1. So what is 10 times 4 to the 5th? So 10,240, but that number is too big. I have to subtract off I need to subtract off the straight flushes, the royal flushes. What about the flushes? We already guaranteed those don't have straights in them. So we need to subtract 40. So 10,200. All right. 3 of a kind. What do we know about these 3 numbers? They're the same number. What do we know about the suits? 3 different suits. And what about the last 2 numbers? They do matter. It can't be a 5. How come? If it's a 5, then we have a 4 of a kind. What else can it be? What about, there's something with the numbers of those last 2. Can't be a 5, and they can't be the same. Because if they are the same, that's called a full house. Okay, so how many ways are there to choose that number? 13, choose 1. How many ways are there to pick those suits? Now wait a minute. It's either 4 choose 1, 3 choose 1, 2 choose 1, or 4 choose 3. We have to ask, if I rearrange the suits, does that change the hand? No. So I calculate them together. So of the 4 suits, 3 of them show up in that hand. In whatever order. It doesn't matter. Okay, what do I know about the last 2 cards? It's not a 5, so how many numbers do I have to pick from? 12. Now, is it 12-1, 11-1, or is it 12-2? Well, if I switch the 8 and the ace, does that change my problem? No, so it's 12-2. But once I have the 8 in place and the ace in place, does changing the suits change the hand? So if I had 8 of diamonds, ace of clubs, or ace of clubs, or 8 of clubs, ace of diamonds, are those 2 different hands? Now careful, they're worth the same, but they're 2 different possibilities. It does. So if the possibilities are different, I calculate them separately. So how many options for the first suit? 4 choose 1. And I have to do them separately because it matters if we change them. How many options for the second suit? 4 choose 1. So this is 13. This is 4. Yes, they can. So what is 12 choose 2? 66. So what is 13 times 4 times 66 times 16? Yeah. 54,900 and... Now that might look like a lot of possibilities, but when you divide it by 3.5 million, or 2.6 million, it's not that much. Okay, 2 pair. What do we know about 2 pair? 2 pairs of different numbers. That's important. Okay? And if I change the order of the pairs, does that change my hand? If you have king, queen, and I have queen, king, that's the same hand. So, do we calculate them separately or together? Together. So, we're going to calculate these together. Of the 13 numbers, how many am I picking? 2. Okay? Now, the suits. If we both have king 7, and I have black cards and you have red cards, or sorry, I have all black and you have all red, are those 2 different hands? They're worth the same, but they're different hands, right? It's a different possibility, so I have to calculate the suits separately. The numbers get calculated together, but the suits get calculated separately. How many options are there for those 2 suits? 4 choose 2. And how many for those 2 suits? 4 choose 2. So inside, it doesn't matter if I switch the suits. But outside, it matters if I switch the suits. So this is kind of a combination within a permutation within a combination. So it's kind of confusing. Okay. And then what about this last card? What do we know? Not a king or 7. 11 choose 1. What about its suit? Could be anything. 4 choose 1. Okay, I'm going to let you calculate that. We're running out of time. So, 1 pair. What do we know about 1 pair? We have a pair of 2s. What about the other 3 cards? Sorry, we have a pair of 6s. The other 3 cards can't be a 6 and can't be the same. So how many ways are there to choose this? 13 choose 1. How many ways are there to choose the numbers here? There are 12 numbers left. Is it going to be 12, 11, 10, or is it going to be 12, 3? Well, if I change the order of the numbers, does that change the hand? No. So 12, choose 3. Now the suits. How many ways are there to choose those suits? Out of the 4, I'm picking 2. Okay? If I keep the numbers the same and I change the suits, does that change the hand? Yes. So I need to calculate them separately. How many for the first one? 4, choose 1. And the other 2? Right. 4, choose 1, 4, choose 1, 4, choose 1. So I'm going to raise that to the third. What about a high card hand? A hand with nothing in it. What do we know about that? How do we guarantee that none of the numbers are the same? You can do it in one calculation and guarantee that none of the numbers are the same. How would you do it? Well, okay. So we're going to pick 5 cards. Does it matter which number we pick first? If I rearrange the numbers, does that change the problem? So do we calculate them individually or together? Together. So 13, choose 5. Yes. Of the 5 cards, all 5 of them are different. So 13, choose 5 guarantees that they're all different. Okay? What about the suits? Well, but what if it can't be a flush, right? And they can't be in order. So the first card is 4, choose 1 for the suit. What about the second? 4, choose 1, and so on. So I'm going to raise this to the 5th. But all that guarantees is that I have no pairs. So that number is going to be too big. So how do I get it down smaller? Subtract the royal flushes, subtract the straight flushes, subtract the straights and the flushes. And that will give me the number of high card hands, which is like it's like 1.3 million or something like that. Yeah. Okay, turn the page. Your homework. The dice are nice, and this is, if the bell rings, just hang out for a second because you'll want to hear this. Dice and cards are totally different. Okay? If you have cards, do duplicates exist? Well, you can have 2 3s, but they're different suits, so there's no duplicate. So that's a combination. But with dice, can you have duplicates? Yes. So one way to think of it is make all of your dice different colors. Or you just, well, either way, you're going to count it as a permutation with replacement. So let's say you have 1 dice and you roll it over and over and over. You roll it 5 times and you write down the numbers. So what you're doing is creating a 5-digit number where the digits are anything 1 through 6. So if I have 5 places, how many options are there for dice 1? 6. So it's going to be 6 to the 5th, which is 7776. So you need to think of this as a 5-digit number. If I change the order of the 5-digit number, do I change the number? Yes. If I change the order of the 5-digit number, do I change the number? Yes. So, how many 5 of a kind hands are there? Well, we could have all 1s, all 2s, 3s, 4s, 5s, and 6s. So for the first slot, there are 6 choices. What about the second slot? 1, don't go anywhere. 1, 1, 1. Okay, that's easy. So it's 6 out of, or not, sorry, yeah, 6 out of 7776. What about 4 of a kind? How is that going to change this calculation up here? That would be a 5, but is this the only place that the non-number goes? It could go in any of them. So it's 30 times 6, choose 1. Right? Because there are 6 places for this one number to go. So 30 times 6, choose 1. Well, what if I change this to a 5, 4? So this is a 3 of a kind. Well, how many places are there for this to go? And this one to go. So you need to figure that out. Okay, it's kind of complicated, but I have given you the answers. Good luck.